Imagine turning on your tap, expecting a refreshing glass of water, but what if that water held a hidden danger? Have you ever noticed a bad smell while taking a shower? In fact, this unpleasant odor is a sign of excessive sulfate in the groundwater. Excessive sulfate would pose serious risks to public health and infrastructure. Immediate effects include gastrointestinal distress, especially diarrhea. Vulnerable populations like infants and the elderly are most at risk. Sulfate contamination can mobilize arsenic in groundwater. Arsenic exposure leads to severe health issues, including cancers. High sulfate levels also corrode water infrastructure. Addressing this issue is crucial for health and water system integrity. However, sulfate in groundwater is often overlooked in water quality assessments. It's crucial we better understand this risk. Researchers from the Hong Kong University of Science and Technology, in collaboration with researchers from Princeton University and City University of Hong Kong, have worked to understand the distribution and levels of sulfate in groundwater. They developed first global-scale high-resolution groundwater sulfate map and assessed population at risk. This study employed advanced data-driven approaches, analyzed more than 17,000 sulfate concentration measurements in conjunction with global geospatial datasets of various variables to map the global distribution of sulfate in groundwater. The result is a 1 km resolution map showing sulfate exceedance probabilities and populations at risk. Unfortunately, groundwater sulfate exceedance is not a localized issue, but rather a global challenge. The findings are alarming. Sulfate contamination is prevalent in numerous countries spanning across continents. Millions of people around the world are unknowingly consuming water with dangerously high sulfate levels. The study reveals that 156 countries have groundwater sulfate concentrations exceeding 250 mgl, with approximately 194 million people exposed to these excessive levels. Even more concerning, an estimated 17 million people face higher risks living in areas where sulfate concentrations exceed 500 mgl. This highlights the urgency of addressing this issue on a global scale. While the problem is widespread, certain regions face a disproportionately higher risk. Among the top 20 countries with excessive sulfate levels, 11 are in Asia, with China having 33 million people affected, mainly in eastern and northern regions. Moreover, over 50% of the populations in the UAE and Qatar are also impacted. In highly excessive regions, India has 3.3 million affected, mostly in the northwest. Besides, in Tunisia, over 70% of the population is affected. Understanding the sources of sulfate contamination in groundwater is crucial for developing effective mitigation strategies. These sources can be broadly categorized into natural and human-induced factors. Natural sources often stem from the geological formations in certain regions. Sedimentary rocks, which are naturally rich in sulfur compounds, can leach sulfate into groundwater over time. Coastal areas are particularly susceptible due to seawater intrusions. However, human activities have significantly exacerbated the problem of sulfate contamination. Intensive agricultural practices, such as the overuse of sulfur-containing fertilizers, are major contributors. When these fertilizers are applied to fields, excess sulfate can leach into the soil and eventually contaminate groundwater. Industrial activities, including mining, fossil fuel combustion, and wastewater discharge, also release significant amounts of sulfate into the environment. These practices can lead to localized hotspots of contamination, posing serious risks to nearby water resources. This study first time incorporated unique human-related variables to predict sulfate exceedance in groundwater and highlighted how human activities contribute to groundwater sulfate contamination, distinguishing it from natural sources. Governments should enhance monitoring, enforce sulfate regulations, and manage agricultural and industrial practices to mitigate sulfate risks. For some regions, existing regulations may need updates, and more research is needed on sulfate's long-term effects, including its role in arsenic contamination. Overall, recognizing the risks of sulfate exceedance in groundwater and safeguarding this vital resource are crucial for public health and a sustainable future. By acting decisively and collaboratively, we can ensure safe water for all.